Imagine a small, mysterious rock silently orbiting near our planet, a rock that might hold the key to nothing less than the origin of Earth's water, or even life itself. Now picture a spacecraft, bristling with robotic arms and state-of-the-art drills, preparing to chase and land on that rock before venturing even deeper into uncharted interplanetary territory. This isn't science fiction. This is China's Tianwen-2 mission, and it's about to make scientific history, while raising geopolitical tensions to a whole new level. But what secrets will it uncover? Could it challenge everything we thought we knew about where we come from? Stay with us, because this is the story of a bold gamble by one of the world's rising space powers. The mission that could change the world's understanding of the solar system and spark a new era of competition in space. Before we dive into the drama, let's lay the groundwork for what is shaping up to be one of the most intriguing space missions of the 21st century. Why are scientists, from China to Europe and the US, so obsessed with two unassuming space rocks, Kamoʻoalewa and 311P Pan-STARRS? Why is the world suddenly looking at asteroids not just as potential threats, but as cosmic time capsules, and maybe even as resources for future industries? First, the basics. Tianwen-2, which launches in 2025, is China's second major deep space science mission, named after an ancient Chinese poem that means questions to heaven. And this time, the questions are truly cosmic. The plan? Visit not just one but two incredibly rare and mysterious celestial objects. The first target, Kamoʻoalewa, is what's called a quasi-satellite of Earth. It's a small asteroid, roughly 40 to 100 meters across, that hovers in a strange, super-close orbit that keeps it near our planet, but untouched by our gravity. Some astronomers believe it could be a fragment of the moon itself, sent flying by a cataclysmic impact hundreds of millions of years ago. But Tianwen-2 isn't stopping there. After a daring sample collection, the spacecraft will kick off on a years-long journey to a second target, 311P Pan-STARRS, an object that blurs the line between asteroid and comet. Scientists call it an active asteroid. It periodically sprouts comet-like tails of dust, as if caught in the act of transformation. Nobody has ever visited anything like it. The stakes? Nothing short of the origins of water on Earth and the possibility of new clues to extraterrestrial life. Let's rewind a moment. Why such a focus on asteroids? For decades, planetary scientists saw asteroids as cosmic debris, little more than leftover building blocks from the solar system's chaotic youth. But in the last decade, that perception has flipped on its head. Missions like NASA's OSIRIS-REx, which touched down on asteroid Bennu, and Japan's Hayabusa 2, which sampled Ryugu, delivered astounding results. They found organic compounds and, crucially, signs of water. Dr. Dante Loretta from the University of Arizona put it bluntly, "Finding organic compounds and signs of a watery past on Bennu brings us closer to understanding the origins of our solar system." If asteroids are cosmic archives, some may contain the very ingredients that created our oceans, and possibly kick-started life itself. That's why Kamoʻoalewa and 311P are such hot properties. Each represents a distinct chapter of solar system history. Kamoʻoalewa might be a chip off our own moon. 311P, with its mysterious dust tails, could reveal how water and organics move around the inner solar system. But there's more to Tianwen-2's ambitions than just science. This mission will showcase a set of technologies that sound ripped from a Hollywood blockbuster: the anchor and attach sampling system. Instead of just brushing the surface like previous missions, Tianwen-2 will attempt to land on Kamoʻoalewa, drill into it, and attach itself securely. No easy feat on a body with barely any gravity. This approach is risky, but also revolutionary. As Dr. Patrick Michel of the French National Center for Scientific Research warns, to get into orbit, you really have to get very close, and even if you just follow it, the maneuvers remain very sensitive, because there's really very little gravity and its rapid rotation forgives no mistakes. The mission will carry out its complex ballet in space for over a decade, far longer than most planetary probe missions. And if successful, Tianwen-2 won't just bring back dust and rock. It could bring back answers to some of humanity's oldest questions. Let's zoom in on the first target, Kamoʻoalewa. Discovered only in 2016, it was quickly recognized as the most stable of Earth's quasi-satellites. Its orbit, though close, is subtly different from our own. Every April, it comes closest to Earth, a cosmic neighbor, but at a safe distance of millions of kilometers. Its origins are hotly debated. Some orbital models, and its lunar-like color spectrum, hint that it could be lunar ejecta, a piece of the moon blasted free by an ancient asteroid strike. But there's no confirmation, no sample, no direct analysis. As Marco Fanucci from the European Space Agency explained, the sample returned to Earth would help clarify the origin of Kamoʻoalewa, and in particular, it should give an answer to whether it originated as lunar ejecta or not. Now let's talk about the second target, 311P Pan-STARRS. This is not your garden variety space rock. 311P orbits in the asteroid belt between Mars and Jupiter. What sets it apart is its highly active nature. At times, it develops as many as 6 distinct tails. Unlike comets, which spew gas and dust as they warm near the sun, 311P's activity defies easy explanation. Some theories suggest it's spinning so fast that it's shedding material. Others think it might be experiencing landslides or electrostatic eruptions. No spacecraft has ever visited such an object. Why does China want to tackle both these targets in a single marathon mission? The answer lies at the intersection of scientific ambition and international competition. The Tianwen-2 mission represents a significant step in China's new journey of interplanetary exploration, says Shan Zhongde of the China National Space Administration. China is seeking not just to join the elite club of solar system explorers, but to leapfrog into the front ranks, setting the pace with technological firsts and scientific breakthroughs. Bold ambitions indeed. But can China deliver? The mission's engineering challenges are hair-raising. Tianwen-2 must rendezvous with a rapidly spinning tiny object in deep space, a little like docking with a grain of sand moving at tens of thousands of kilometers per hour. Then, it must anchor itself, scoop up samples in microgravity, survive the hazards of space for years, and finally, return its precious cargo to Earth. There's more at stake than just the science. If Tianwen-2 conclusively proves that Kamoʻoalewa is lunar debris, we could see a new, and potentially contentious, space race. Who owns fragments of the moon scattered across space? If the samples contain never-before-seen resources, or evidence of ancient water, or organic materials, the geopolitical and economic implications could be enormous. Imagine the claims, the patents, the scramble for mining rights, not just on the moon, but on interplanetary debris itself. China's timing is no accident. Following the successes of OSIRIS-REx and Hayabusa 2, the international appetite for asteroid mining and exploration has exploded. The anchor and attach method developed for Tianwen-2 could offer a blueprint for future commercial missions, mini-mining operations on distant rocks. Wei Yuanming of the China Aerospace Science and Technology Corporation succinctly summarizes the stakes. We aim to run the first leg of the race well. But amid the excitement, serious doubts linger. The world has seen high-profile space missions falter at the final hurdle. Just last year, a Japanese lunar lander crashed in the final minutes of descent. Mars rovers have frozen, satellites have gone silent, and sample return capsules have burned up in the atmosphere. Will Tianwen-2's decade-long journey survive the cruel gauntlet of space? And then there's the rivalry. The United States and Japan have made clear their own asteroid ambitions. Europe has a string of plans on the drawing board. International collaboration is one possibility, but so is cutthroat competition, as each nation hopes to secure samples, data, and intellectual property for its own scientists and industries. Yet perhaps the most tantalizing question is a scientific one. Dr. Teddy Kurita of Lowell Observatory, a member of the team that discovered Kamoʻoalewa, says it best. Both Kamoʻoalewa and 311P Pan-STARRS are incredibly interesting targets that stem from populations of objects that, up until a couple of years ago, astronomers barely knew existed. Could these objects upend our entire understanding of the solar system's evolution? Is there proof among these rocks that Earth's oceans and life have truly cosmic origins? Looking ahead, the success of Tianwen-2 could unlock a storm of opportunities and questions. If it proves Kamoʻoalewa is lunar debris, the international space community will be forced to grapple with new legal and ethical challenges. If it uncovers new organic molecules or hints at extraterrestrial life, the implications could be staggering. As Yuki Qian of the University of Hong Kong puts it, all Chinese planetary scientists are now finger-crossed for this historic mission. So, as Tianwen-2 prepares for launch, one question lingers. Can China's bold new mission survive the risks, outpace the competition, and answer some of humanity's most profound cosmic questions? Or, as with so many grand ventures into the unknown, will the greatest surprises still be waiting out there, far from Earth, on two tiny but world-changing rocks? The answer may be closer and stranger than anyone expects. As we now pivot toward the future, the world is holding its breath. The Tianwen-2 spacecraft, humming across millions of kilometers of empty space, represents far more than a single nation's technological prowess. In its titanium belly rides the hope of cracking open some of the solar system's best-kept secrets, and perhaps rewriting what we know about the origins of our own planet. But what lies ahead is a swirling tempest of scientific intrigue, political maneuvering, and existential questions. The risks are enormous. The potential payoffs, even greater. Let's begin by imagining the coming years as Tianwen-2 closes in on its first target, the enigmatic Kamoʻoalewa. This tiny quasi-satellite circles the Earth in tandem, almost like a cosmic twin, but with an origin shrouded in mystery. The Chinese team must execute a ballet of precise maneuvers, matching speeds with a rock that's not only tumbling through the void, but also barely clings to its own gravity. Any mistake, no matter how tiny, could spell disaster. As Dr. Patrick Michel from the French National Center for Scientific Research bluntly states, to get into orbit, you really have to get very close, and even if you just follow it, the maneuvers remain very sensitive, because there's really very little gravity, and its rapid rotation forgives no mistakes. Should the team succeed in landing, the anchor and attach technique, the first of its kind, will swing into action. Robotic arms, bristling with drills and sensors, will bite into virgin regolith. If they manage to extract a pristine core and return it to Earth, it could resolve a question that has haunted astronomers for years. Is Kamoʻoalewa a chunk of the moon, blasted away by an ancient collision, or something much, much older? According to Marco Fanucci of the European Space Agency, the sample should give an answer to whether it originated as lunar ejecta or not. If confirmed, this would mark the first time humanity has recovered a lost fragment of the moon, possibly setting off a scramble among nations to comb the skies for other pieces. Imagine a new kind of space race, not for the moon itself, but for its wayward children scattered throughout the solar system. Ownership, resource rights, and even new legal frameworks for off-world material could be thrust into the global spotlight. Who gets to claim a lunar rock that spent eons drifting through space? But Tianwen-2's ambitions don't end there. After sampling Kamoʻoalewa, the spacecraft will slingshot further into the asteroid belt to approach 311P Pan stars, an active asteroid whose very existence challenges conventional wisdom. Unlike ordinary asteroids, 311P periodically erupts with comet-like tails, a phenomenon that has never been studied up close. If Tianwen-2 succeeds, it will be the first mission in history to directly investigate an active asteroid. The scientific community is watching closely. Both Kamoʻoalewa and 311P Pan stars are incredibly interesting targets that stem from populations of objects that, up until a couple of years ago, astronomers barely knew existed, says Dr. Teddy Kurita of Lowell Observatory. Why does this matter? These bodies might hold clues to the origins of water and organic molecules on Earth. If Tianwen-2's instruments detect new types of complex organics, or if traces of water are found locked within primordial rock, the implications are staggering. Could it be that Earth's oceans and the seeds of life were delivered not by comets, as once believed, but by asteroids or quasi-satellites like Kamoʻoalewa? The possibility even exists that Tianwen-2 could detect something completely unexpected, an unfamiliar mineral or a molecular relic from the pre-solar nebula. As Keiko Nakamura Messenger, a veteran of NASA's sample return missions, has said, "Sample return missions always give us a big surprise. History suggests that each time we bring back a piece of the cosmos and peer inside, we end up with more questions than answers." But alongside wonder, there's tension. As more nations, China, the United States, Europe, Japan, race to retrieve extraterrestrial samples, the stakes are becoming as much geopolitical as scientific. The notion of firsts in space exploration is loaded with symbolism. As Wei Yuanming of China Aerospace Science and Technology Corporation put it, "We aim to run the first leg of the race well." If Tianwen-2 uncovers transformative secrets, China's position as a space power could skyrocket. New discoveries could spark a surge in funding, innovation, and a host of follow-up missions, not just by China, but by other nations eager to ride the wave. Will this competition spark a golden era of exploration or breed new forms of rivalry? And then, consider the unthinkable. What if Tianwen-2 fails? A botched landing, a failed sample collection, a catastrophic malfunction. Any of these could cast a shadow over China's space program, tightening the leash on future funding and sending competitors scrambling to fill the void. Every step is a high-wire act. For the scientific community, the future is both thrilling and daunting. As Dr. Shan Zhongde of CNSA puts it, the Tianwen-2 mission represents a significant step in China's new journey of interplanetary exploration. Each maneuver, each byte of data, is a gamble, with the promise of rewriting textbooks or the risk of reinforcing old uncertainties. But what does all this mean for us, watching from the comfort of our screens, ground-bound but hungry for knowledge? First, it's a powerful reminder that exploration is no longer the domain of one or two nations. The sky is open, and the quest for cosmic knowledge is rapidly becoming a global pursuit. Every success and failure inspires not only pride, but also humility. We are participants in a scientific quest that stretches across borders and generations. Second, Tianwen-2's mission embodies a lesson in perseverance and risk-taking. Giant leaps are never without setbacks. Whether it's the anchor and attach method or venturing to a never-before-studied comet-asteroid hybrid, the mission exemplifies how progress is often built on the willingness to attempt what's never been done before. Much like China's bold approach, anyone, whether a student, a researcher, or a lifelong learner, can draw inspiration. Breakthroughs demand curiosity, grit, and the courage to fail. Third, the practical benefits of such missions are more far-reaching than many realize. Technologies innovated for Tianwen-2, precision robotics, autonomous navigation, advanced sample containment, could eventually trickle down into industries here on Earth. Similar breakthroughs from past space missions now power our smartphones, medical devices, environmental monitoring, and even logistics networks. Each line of code and each mechanical innovation holds the potential to spin off into a dozen Earth-bound applications. Moreover, the sheer scope of Tianwen-2's scientific objectives, seeking the building blocks of life, the origins of water, the fate of lunar and asteroidal fragments, raises philosophical questions. Where do we come from? Are we alone? Could life be seeded elsewhere, waiting to bloom? The samples retrieved may not just tell us about the past, they may point us toward our future. For students and young scientists watching, now is the time to get involved. The international nature of these missions means there are more opportunities than ever to join collaborative projects, contribute to data analysis, or even participate in mission planning. Keep a close eye on calls for proposals and internships. Your career could blast off alongside Tianwen-2. And for viewers passionate about space, your curiosity matters. The public's excitement and thirst for discovery are what drive funding, media attention, and, ultimately, political will. Don't underestimate the power of a well-timed question on social media, a letter to a representative, or supporting educational outreach. Our collective wonder is what sustains these cosmic odysseys. So, as Tianwen-2 embarks on its perilous journey, we hold our collective breath. Will the engineering gambles pay off? Will the robotic arms retrieve samples that answer humanity's oldest questions? While there are no guarantees, history shows that every time we look to the stars, we come back changed. And now, let's return to that central intrigue. Will Tianwen-2's risky maneuvers succeed, and what world-changing secrets could its samples reveal? While the laws of physics and the cold indifference of space offer no promises, Tianwen-2 is built on the best of human ingenuity and a little bit of hope. Should its robotic arms clutch fragments of Kamoʻoalewa and its sensors probe 311P pan-stars, we may, for the first time, directly trace the journey of water, organic molecules, and perhaps even lunar debris across the inner solar system. The answer to whether Kamoʻoalewa is lunar ejecta could herald a new era of space law, with nations racing not just to the moon, but to claim its cosmic orphans. Meanwhile, the samples from 311P could redefine what we know about the birth of planets and the prevalence of life chemistry in our neighborhood. But here's a secret fact. Tucked within Tianwen-2's extended decade-long journey is a silent revolution. Its dual-target, long-duration approach is a blueprint for the next generation of planetary missions. By not only visiting but interacting with and retrieving samples from multiple bodies, Tianwen-2 quietly poses a challenge to the world. Are we ready for multi-object, multi-decade space exploration? The answer, one way or another, will shape how humanity ventures into the cosmos for decades to come. As we wait for each mission update, each press release, remember, space exploration is not just a contest or a curiosity. It's a mirror, reflecting our deepest yearnings, our boldest challenges, and our willingness to leap into the unknown. Tianwen-2's odyssey is now part of our shared story. If you want to stay updated on Tianwen-2, unravel more cosmic mysteries, and join a community passionate about the next great leaps in science. Don't forget to subscribe, hit the notification bell, and share your thoughts below. What question would you ask?